All right. So we are going to get started. Um, just real quick, for the end of the week, we're going to have a quiz review and a quiz. So, make sure you have as much of your work done as you can. 4-week progress reports are going out tomorrow. I'm sorry, grades are due tomorrow. So everything from 8.1 to 8.3 needs to be completed. If you haven't, and then the quiz today is on 8.4 to 8.6. And we'll take a look at that here in a moment. So we're gonna review a little bit from what we did on Monday with linear, exponential, and quadratic models. Before we do that, we do have a little bit of a different schedule next week. So next week, cohort A meets Monday and Tuesday, but only for 50 minutes. So from 8:30 to 9:20 for first hour, 9:25 to 10:15 for third hour, 10:20 to 11:10 for seventh hour, and then 11:15 to 12:25 for fifth hour because of lunch. For cohort B, same schedule, same class times, but obviously on Thursday and Friday. And then starting on the 26th, there are no more cohort A, cohort B things happening for the in-person classes are both cohorts together. So, and then we'll be back to that regular schedule that we have like for today. So a little bit of a change for tomorrow or for next week. And next Wednesday, there are no scheduled office hours on Wednesday. However, if you have a question, feel free, email me, let me know. And I will certainly make time to work with you and get your questions answered. All right. Question about next week's schedule. All right, then we're just going to talk a little bit about kind of quickly review what was done on Monday. So again, I'm not going to take the time we're not going to go over any of the examples, but just this is kind of the bulk of the information you're going to need to know. So talking about linear, quadratic, and exponential functions. A linear function has a constant rate of change. And we generally have two different ways we write linear functions, either slope-intercept form, which is y equals mx plus b, or standard form, ax plus by equals c. There is a third form that's not used very often, called point slope form. But we're not going to have any examples like that. You won't see them in the homework or in the quiz or the review. If we look at a table of values, the y values change by a constant or consistent either sum or difference. So for instance, for this table of values, we can find the first difference, easy for me to say, by taking a y value minus the previous. So 1 minus -1 is 2, 3 minus 1 is 2, 5 minus 3 is 2. If the values were going down, then it would just be a negative pattern instead of positive. Graph of a linear function is a line. And a situation, or in a word problem, you're going to see like amount of money per hour, or things of that nature. Quadratic functions, those are our parabolas. Those are really what we've been spending a lot of time on this trimester. A parabola, a quadratic function shows increase and decrease. So you can see on the graph, it goes down and then it goes up. And we have 3 different forms of the equation. The big thing to remember, this is, we're going to have an x squared, which we wouldn't have in a linear function. So we have our standard form, ax squared plus bx plus c. We have our vertex form, y equals a times x minus h squared plus k. And our intercept form from the beginning of work that we started since spring break, y equals a times x minus p times the quantity x minus q. With a table of values in a quadratic function, if you take and subtract consecutive y values, you don't get the same first difference, but then if you subtract again, you get a common second difference. So again, looking at the table of values, -3 minus 0 is -3. -4 minus -3 is -1. -3 minus -4 is +1. So the first difference are not the same, but the second difference, -1 minus -3 is +2, and 1 minus -1 is +2. Second degree difference is the same. Situations that can be modeled with quadratic equations and graphs and tables would be our vertical motion problems. When something is being thrown or launched or kicked or dropped, all of those things are going to have a quadratic model and a parabolic shape. The new type of function is this thing called an exponential function. And exponential function is a function, partially curved line, that shows very fast either increase or decrease. And decrease, a common word for that is decay. So if you look at the graph, this is the blue one here. It shows exponential increase or growth. And then over here, the one I'm highlighting in green would be exponential decay. Okay, and again, this one up here is exponential growth. The equation has x as its exponent, which is, again, something we haven't seen previously. So we have y equals some value a times b to the x. And another way that it's commonly written is, I kind of like it with the exponent inside of the parentheses. I like it that way. It could even be written without parentheses. I like the parentheses because it really shows, hey, that b is the only thing being taken to the x power. The table has either a multiplication pattern. We're either multiplying by a whole number or by a fraction. So for exponential growth, like this, again, the blue function, we go from 0.5 to 1 to 2 to 4. And each time we're multiplying by 2. So it's still, if you just had a table of values to work with, I would check the first and second differences. And if they weren't the same, then I would see if there's a multiplication pattern. If it was decay, like the one highlighted in green, that might be look like you're dividing by the same thing, like maybe by 2. But remember, dividing by 2 is the same as multiplying by 1/2. And that's usually the way it is described. Excuse me. A situation that might model exponential growth or exponential decay. If something doubles, like a lot of times you'll hear about population doubling or tripling, quadrupling over a set amount of time, that would be exponential growth. It could also you get a half or a third or 2/5 over time. Sometimes, like in chemistry, they talk about the half-life of an element. Again, could also be something that increases or decreases by 1% each year over time, or the reproduction of animals or bacteria or humans or whatever. That would, at least in the beginning stages, be represented by exponential growth. All right. Just again, 8.4, we talked about intercept form, which is kind of a factored form of that quadratic. Ax minus p, x minus q, where p and q are the x-intercepts. And we could either take the x minus p, set it equal to 0 and solve for x, or just remember that we're getting the opposite value for our x-intercepts. If we know our x-intercepts, our axis of symmetry is going to be halfway between. So we can take p plus q and divide by 2. And then to find the vertex, we do exactly what we did with vertex form. We take the axis of symmetry and, I'm sorry, with standard form, take the axis of symmetry value, plug it in for x in our function to get the y coordinate for the axis, for the vertex. So the x coordinate is always going to be the same as the axis of symmetry. We just need to plug that in into our original equation to find the y coordinate. And then remember, the value for a tells us if we're opening up or opening down, and how wide that opening is going to be. So for the review, you'll have problems like this. Hey, here's an equation in vertex, in intercept form. Find the intercepts, find the axis of symmetry, find the vertex, find the y-intercept. And again, the y-intercept, you just plug 0 in for x and evaluate the expression. I believe those are all fill in the blanks. Then some matching. Here are equations in intercept form. I'm going to say it right this time. You need to match it with the correct graph. All right, then converting to standard form. So multiplying out using FOIL or the box method. And again, you'll be filling in the coefficients. Notice that the signs are already there. So if you get a negative 3x, you just have to put the 3 in the box. Um, 8.5, we talked about applications, things like finding the area of a rectangle. again. So you would multiply that out and using box or FOIL and fill in the coefficients and then evaluate for x equals 6. So then plug 6 in for x and tell me what the answer is. And then similar, we did one with a swimming pool and a deck. But here the situation is the same idea. We have a rose garden and red roses in the middle and yellow roses around the outside. Same sort of idea there. That also led us to our vertical motion problems, where the equation h of t is equal to negative 16t squared plus v sub 0 times t plus h sub 0, where h of t represents the vertical height at any time t. V sub 0 is the initial velocity or speed, usually in feet, but in this case, it has to be in feet per second. H sub 0 is initial height in feet, and then t is time in seconds. So one situation, you'll be told, hey, a rocket is launched from a height of 25 feet with an initial velocity of 80 feet per second. Fill in the values, a little drop-down menu. When will it reach its maximum height, and what is the maximum height? Remember, that's just your vertex. So finding the vertex when we're in standard form. And then there'll be just choosing which type of model. Again, drop-down menus. So you're just selecting either linear, quadratic, or exponential. Matching the type of function with the name, either linear, quadratic, or exponential. Obviously, there are more than 3, so answers can be used more than once. And then telling what the table shows. Is it a linear function, quadratic function, or exponential function? All right, and then that's it. So any questions about the quiz review?